So now this is part 2 of our video. In the last part we illustrated how the values of 30 and the values of 60 are gotten, and we did it by using an equilateral triangle having sides of 2 units each, whereby we divided, got a right angle triangle, went on to use the Pythagoras theorem, and then we used SOHCAHTOA to get the values. So now in this video we will be knowing how to get the values of 45, the special trigonometrical ratio or angle, rather 45 degrees. So to get it, we usually consider a square having sides of 1 unit each. Now, from geometry that you must have learnt in school, right, a square has special properties. It has equal sides and equal angles. So, and these angles are right angles, 90 degrees, which means they are equal to 90 degrees. So now, and we know that a diagonal can run through this side and also this side. So if we divide it like this, we end up having a right angle triangle once more, just as we did in our first part of the video. So here now, being 90 becomes divided by 2 and it becomes 45 degrees. Here also becomes 45 degrees and here remains 90. So now, here is 1, here is 1. To get the value of the hypotenuse, what do we use? We use Pythagoras theorem as we did in the part 1 of the video. So by Pythagoras, we have the hypotenuse. Let's name that x. X is equals to x squared is equals to 1 here, 1 square plus 1 square. X square will be equals to 1 plus 1. X square will be equals to 2. Therefore, x will be equals to root 2. We don't go further than this. So x now here becomes root 2. That means our hypotenuse is root 2. So now we go ahead and use our SOHCAHTOA. An easy way to remember it, that's it. So now we can use any of this, I believe. So we start sine 45 is equals to, the opposite side to this 45 is 1 all over, the hypotenuse is root 2. As we did in the part 1 of this video, we rationalize. Root 2 will come here, we multiply the numerator by root 2, multiply the denominator by root 2 also. This will give us root 2 all over the square root of 2 times 2, which will be root 2 all over root 4. So this will now give us root 2 all over. The square root of 4 mathematically is 2. So this will give us root 2 all over 2. So sine 45 is root 2 all over 2. Now for cos 45. Cos 45 is equals to, so cosine is equals to adjacent all over hypotenuse, right? So the adjacent side to this angle is 1 all over the hypotenuse, which remains root 2. When we rationalize as we did above, we get the same thing. We get root 2 all over 2. Now we move on to tan 45 degrees. Tan 45 degrees will be opposite all over adjacent as we have been doing. So it will be the opposite side now to the 45 is this one. 1 is the opposite side. We write 1 all over. The adjacent side is 1. That's 1. So it makes tan 45 to be 1. So these are this is the way that we derive 45 degrees. Sine 45 is root 2 over 2. Cos 45 is root 2 over 2. Tan 45 is 1. Thanks for watching.